So today we're going to focus on network analysis. And next time, since we are pretty flexible, next time we didn't have anything scheduled because I was planning to have 3 article reviews next week, but since there are some changes, so next week we can spend more time on other components of transportation. So some of you mentioned the transit-oriented development. So we can talk about GIS and TOD and also some additional accessibility analysis, which I felt like, if I recall things correctly, I think Amy's presentation will also work very nicely into the topic on presentation. So we'll have some more information on that. So in terms of network analysis in ArcGIS, so I just give you all the terms here, which are, whenever you're reading something about network analysis tools, you will see these terms very frequently. So that's the reason why I'm also want to just talking about the terminology. So within a network, so I want to first of all make things clear. Even though we're using the street centerline data, but the street centerline data itself is not going to be a network. It's only a line data. So the difference is a network data. So I'm kind of going backwards. A network data is actually a collection of vertices and edges. So for vertices, we're talking about the point locations which are considered as the nodes, the network nodes. And those locations, those points, those vertices are typically the ending points, which can be the starting points of a street or intersection points of between the different lines. So within a network, for a layer or for a data set to become a network, we need both the points and lines because they together model the connectivity, the turns, the one-way locations. So even though, for the straight center line data, we know it looks like lines. We know there are originally, the lines are formed by points, but the center line data itself is not considered as a network. You have to create a network which contains all the vertices, and also the vertices are not every single point. That would be the specific points that representing the network nodes. And for the edges are basically the lines, which are sometimes called links or arcs. So those are the links between 2 vertices. For example, basically a road intersection is considered as an edge, and they can be directed or undirected. So directed means they follow certain direction. So this is different than your 2-way or 1-way street. So for directed, there is a certain predefined direction. So actually for transportation networks that we model within ArcGIS, they are undirected. So usually, like in general, you would allow traffic to happen either way, both ways. However, you can further define some additional attributes to control one-way street. And also maybe you can control, they can only turn through a certain, at a certain vertex or a certain node, the traffic can flow one way. So there are some additional attributes, but also in terms of the network analyst, we're talking about they're undirected, which would allow traffic to happen both ways. Check.
I was going to ask it. I was just to clarify for myself, directional would be a one-way type of traffic. Undirected would mean both ways could be, it could be happening both ways. Okay, I just want to make sure.
Yeah, and also I guess I would say, whenever we're talking about the transportation network, I would say we're talking about, even if you're talking about one way, still going to be undirected, with limits. Because the directed flow can be, because the terminology here, we're talking about, generally speaking, there is not only transportation network, it can be utility network or some other types of network. So the directed network would be like flows, maybe like flow of rivers, flow of waters. So they flow through certain directions. And in ArcGIS, the network analyst, the network data set, they are undirected, which would allow you to control is only allowed in one way or another. But it's actually just a terminology difference. So I just want to point out the edge can allow both ways, if that makes sense. And also, I want to introduce another term called graph. So essentially, a network is considered a graph. A graph is a collection of vertices and edges. Basically, they form a graph. But the term here is important because a lot of this network analysis algorithms, they may come from the graph theory. So in terms of the research side, we're interested in transportation or utility or anything spatial, GIS, geographical, but also a network can be more generalized. They can be talking about totally virtual networks, maybe just a geometry problem and looking at the connections between different nodes and different links and how the flow happens and all the other attributes. And also there's another related term called path. So the path here refers to a certain portion within your network. So it's usually a sequence of connected edges between vertices. So for example, if you're modeling the routes traveling between two locations, maybe from a starting location to a ending facility, what you're analyzing or your result would be a path. So it's kind of a portion of the network that follows your criteria, maybe the shortest in terms of travel time, or maybe the optimal that would pass through a couple stop locations in between. Let me also quickly check the questions in the chat. Yes, there will be instructions for lab 4, but also we're using a S3 lesson. So that's why I'm going to show you a little bit of, because you have to learn from the lesson and then replicate the procedures to do something for Chicago. And then for transportation networks in ArcGIS, it's usually modeled by network analysts. And this is actually a term that specifically refers to a feature data set stored within a geodatabase. So network analyst or using network analysis in ArcGIS is one of the reasons why you have to use a geodatabase, because the network dataset can only be stored and also only be created within your geodatabase. And they have very specific functions for you to model, like transportation related attributes. Like we already mentioned, they can be used to model travel time, allow you to model the one-way locations, the overpass, and all the other connectivity related issues. And typically, you can build your network dataset from the straight centerline data, which would represent a very generic, like road network, straight locations, the flows within a city, which would be, which can be used for modeling driving time and walking time. And, like in terms of the streets, you can define whether they have the specific sidewalk and all these related attributes for you to model either driving or walking. And in addition, you can also build a public transit-based network. And I can share with you folks of how to create a public transit-based network, which is different than road network because they don't necessarily follow. So in terms of the visual representation, they don't necessarily like model the flow by the streets. However, the public transit-based network would allow you to analyze the schedule like very much like real time. Although there may be delays, but the public transit data set will have the information regarding the daily route, the schedule, the calendar, so you can model more specifically, answer questions more specifically related to public transit. And also your network data set, like we already mentioned, it's more than just the line data. So within your network data set, you'll see a collection of edges, junctions, and turns. So actually, whenever you're adding a network data set to your program, you'll see many different elements. So it doesn't look like your traditional layer is only one item. There are multiple items. They all come together to form a network. And there are some additional information attributes or properties you can further to define your travel cost. I recall Andrew talked about the travel cost. So in this case, you can define your travel cost to be the travel, the total, how long or travel time, or you can also define the monetary attributes. You can also model turns and model one-way streets. And right now, they're really making the tools more functional that would allow you to build, different combination of travel mode and also travel time accordingly. And also the link below has a more extensive terminology list from the network analyst. I'm only talking about a few here because I felt like the other ones may be better to explore through a practical exercise. So just want to talk about the general ideas. And also here are some key research problems in network analyst. So basically with your network data set, there are a couple things you can model within ArcGIS or within some other GIS-based transportation analysis program like Transcat. The typical examples can be you can model the shortest path between origin and destination. So ArcGIS use a very specific algorithm, but a different program they may adapt a slightly different one. So all this different, like for us, we are more interested in applying the tools more than developing the algorithm. So this kind of algorithms behind transportation analysis are mostly researched for computer scientists who are more interested in like spatial and geometry. They can model the flow, develop the algorithms, and then we can apply the tools to solve actual problems. And also with the same algorithm, you can also identify the closest facility. So those are the basic functions. And in addition, they would allow you to build a origin destination cost matrix. So that would be, because we're talking about a matrix, that would be multiple origins and multiple destinations. And what you receive would be only a tabular matrix. So this OD cost matrix, they do not calculate the shapes. Like they don't really like model, for example, for the shortest path, they will delineate the routes from the starting location to the ending location. However, for the origin and destination cost matrix, because they're going to calculate multiple, so there's no specific shape calculated for you. They're only going to calculate the total distance and then give you a matrix just to save the computing time. And of course, there is this famous traveling salesman problem, which is basically you can consider when UPS makes a delivery route, they have to go through multiple steps. So this traveling salesman problem is about optimizing the sequence of stop locations. So it's not only about shortest to one particular location. It's about giving a list of a number of different stops. How do you optimize based on for example travel time or based on the total length of the route. And in addition, we can calculate service area. So that would be again based on travel-based service time. So for example, you can create a isochrone map showing the 10 minutes drive distance to a particular store, or maybe do a half an hour drive time, or maybe half mile distance to the campus location. So for service area, you can identify your facility, and then they will just calculate a network-based buffer surrounding your target facility. So which wouldn't be a circular. So it's, usually go with your network, and also you will again model the the driving directions, and also model the turns, and you can bring in travel time to allow for more complex shapes. And also another related to is called a location allocation. So that would give you the option to choose from a number of candidate facilities in order to minimize the distance to the demanding points. So this is kind of like a distance-based or weighted distance-based site selection problem. So you need to have the candidate's facilities, and then eventually we'll pick the one that can minimize the overall distance to achieve the maximum efficiency. And if you're interested in some of the specific algorithms used by ArcGIS Pro, you can click on the link at the bottom here. So they do have some specific statements for each of those particular analysis options.